Stop, Haley. If we look at problem number 9. All right. Problem number 9 says 14t plus 15 minus 2t. First step, change all subtraction to addition. So, in this problem, we're going to take 14t plus 15, change that to addition, do the opposite of 2t, which is negative 2t. Now, in this, these are our coefficients, and this is our constant. There's only one constant, so we can't put it with anything else. So I'm going to take the one constant and just bring it down here so it's in my answer. Okay? The two things that we can put together is the 14t plus the negative 2t. Now, this part of the problem is the same thing as 14 plus negative 2. 14 plus negative 2 is 12, but then I've got to keep the t with it. So it becomes 12t. And so my answer is 12t plus 15. Can't go any further than that. That's it. It's done. Okay? This term and this term are not the same. One has a t, one doesn't. So it goes back to what I was talking about yesterday. Okay? I can't have, 12 blue backpacks and 15 red backpacks and say I've got 27 red backpacks. I can't do that because they're not the same. Copeland? Okay. So your answer is 12t plus 15, and it's done. That is simplified. Okay?
So you take the constant out?
I didn't take it out. I just...
moved it to the side.
I just moved it to the side because there's no other constants. So basically what I did is I rearranged this. What I did is this right here, I rearranged to be 14t plus negative 2t plus 15. And I put those two things together. And the 15 was the only thing left. Now in a minute we'll talk about the ones that had multiple constants. When they have multiple constants, then you have to add two different things together and get the final answer. Copeland, did you have another question? Huh? Why can't you add them up? Okay. Because it's like, this is what we basically have. Here we have 1 plus 1 plus 1 plus 1 plus 1 15 times. Okay? The other one we have t plus t plus t plus t plus t 12 times. So is there any way to add those up and say you got 27 of one or the other? No. Okay, I got 15 ones and I got 12 t's. I can't put them together and say I got 27 t's or 27 ones. Okay? The other reason we can't put them together is what we talked about yesterday. If I have 12 times 3 plus 15, what are you going to do first in that problem? 12 times 3. Okay? So if that's what comes first in the problem, then how can all of a sudden now I put those two things together and go 27 times t? You would never, in other words, you would never see this problem here and say that that's 27 times 3. Okay, you can't do that. Now, the other reason that I can put those two things together is because of the distributive property. Let's look at that again. That's a mark, both of you. Okay? It's a mark. Don't argue, and it's 3 marks and Mr. Tidwell's office. Now, the reason that I can put these two things together is because of this. See, y'all see the 14t is sort of just like it's not a multiplication problem. Copeland, look at me, so I know you're paying attention. Okay? This right here is like this. That is like 14 times 3 plus negative 2 times 3 plus 15. So if I had this, because we learned the distributive property in Chapter 6, the distributive property says I can take this common 3 with those two and put it outside the parentheses, and on the inside of the parentheses have that. You remember that? Okay. Is there a common 3 right here that I can do that with? No. That's why I can't put them together. The distributive property, the reason I can put those two like terms together is because of this distributive property. Okay? That's the reason we can put those two together, but we can't put the other one together. Okay? Because I can put those two together. 14 plus negative 2 is 12. And that's like 3 times 12. Well, instead of the 3 being there, it's really t. Okay? And so now I've got what I came up with, 12t plus the 15 that I couldn't put there. Okay? All right. Now, let's look at another one. All right, let's look at this one. 4k minus 10 plus 7 minus 7k. Okay, so the first step would be to do what? All right, and so what is that? Hang on. What? Say it again. Right. Okay, so that's changing all the subtraction to addition. Now, so that was step 1. Step 2 is use the commutative property and group like terms together. Okay, so we're going to use the commutative property. So step 1 was here. Okay, step 2 is to take the 4k plus the negative 7k plus negative 10 plus 7. That's step 2. Using the commutative property to have basically this. Okay, I just basically put the things that are alike together. Now, inside of this parentheses, we have 4. So what we have is 4 plus negative 7. So you had $4, and then I took $7 from you. How much money did you lose? $3. Well, let me rephrase that. I gave you $4, then I came back the next day and took $7 from you. How much did you lose? Negative 3. Okay? So that would be negative 3, but I have to keep the k. The k stays the same. just like fractions. When you have 3 over 8 plus 2 over 8, that's 5 over 8. Same thing with the variable. I have 4k plus negative 7k. Put the two together, you get negative 3k. Plus, I just bring down that plus sign, negative 10 plus 7. Do what? Negative 3. Okay? Now, here's where people get confused on two separate areas here. Okay, well, step 3 was put like terms together. Okay, and that is this right here. And let me go ahead and write that other step. Negative 10 plus 7. Okay, here's where people will get confused, and it is a little bit confusing. Okay, these two, first of all, this and this are both negative 3. So people will say, well, hey, they're both negative 3s. I can put them together. They're the same. No. The variables must be the same. I have never said that the numbers have to be the same. I've said the variables have to be the same with the correct exponent. Okay? So you can't put them together even though both of those are negative 3. The other place people get confused, and I understand this, is that this right here, plus negative, we need to change that, since it's our final answer, we need to change it to negative 3k minus 3. Huh? No, it's still the same. You're done. But the book will not list plus a negative. The book will say minus 3k. Or minus 3. Okay? So we need to get in the habit of, when you see a plus a negative in your final answer, you change it back to a subtraction sign. Okay? Just like up here, we change this subtraction sign to what? Plus a negative. So in the end, if you have a plus a negative, you need to change it back to the subtraction sign. That's at the very, very end in your answer. Okay? Now, I want you to try this one on your own. 10x plus 4 plus x minus 9. Remember, there is a 1 in front of that x. Okay? So try it on your own. Give you a couple of minutes here to see if you... All right, what'd you get, Gracie?
I got 4x minus negative 8x.
You got what now? You got what now?
I got 4x minus negative 8x.
No.
Negative 9.
No. Haley, what'd you get?
I got 4x minus negative 9.
No. I don't understand where y'all are getting 4x.
I said 14.
Oh.
14, sorry.
Okay, I don't understand where you're getting 14.
And plus 4.
There's an x with that 4?
Yes. Yeah, there's 14x.
No.
You just...
No. No. No.
Oh.
It's a plus. And A, it's not even that way in the book.
I'm sorry, I thought it was.
Vivica.
So wrong.
Yes.
Good job.
Yes. But remember,
What is it?
11x plus negative 5 is what Vivica said. Remember, that's got to change to 11x minus 5. Okay, now, here's how you get it. First, we go 10x plus 4 plus x plus negative 9. That's the first step. Second step is those two things are the same and those two things are the same. So I rearrange my terms using the commutative property and get this. Now I put those two things together. 1 plus 10, 11x, plus 4 plus a negative 9, negative 5. Thus making 11x minus 5. Do what? What about it? Then don't do it. I just need you to understand that when it's 10x plus x, well, no, don't worry about it. Don't worry about it. I just need you to understand that when there's a 10x and a 1x, or an x, you need to add the two together. It's not just still 10x. You need to understand that there's a 1x there. Okay? All right. Your homework. 7.2. All right. You're going to do 2 through 4. Now listen. You got to simplify those now. Okay? Like we're doing here. And then you're going to do 9 through 14. And you're going to simplify those. Okay? That's what you're doing. The what? No. You've already done that. All you're doing now, listen, all you're doing now is simplifying the problem, like we just did the 3 or 4 we did today. To do on Monday, you may go,